Right, hi guys, Max from LRT, and today we're going to be talking about angle shooting. Okay, in this video we're going to be talking about gravity, we're going to be talking about cosine, solving the actual angle shooting issue, and practical uses, way that can make your life easier. So first off, we need to talk about gravity. Okay, we all know gravity, you jump up, it's the thing that pulls you back down, okay, but how does it affect our bullet? Well, we know that there's an elevation turret on top of our rifle scope, and obviously that deals with gravity. But what actually is going on? Well, gravity is a force pulling your bullet towards the earth as soon as it leaves the barrel, okay? The only reason it doesn't just drop like a stone as soon as it comes out of your barrel is because of velocity. Obviously, we have pushed that bullet out of the barrel at thousands of feet per second, all right? So what actually is the gravity? What is it doing? Well, every second, gravity is pulling your bullet towards the earth at a rate of 9.8 meters per second squared, all right? So every second, that is gonna increase by 9.8 meters per second. So for example, this is our bullet in flight, okay? We're moving this way, obviously towards the earth, all right? After 1 second, we would have accrued a velocity of 9.8 meters per second downwards. After 2 seconds, okay, 19.6 meters per second. After 3 seconds, 29.4, and that's going to increase and increase and increase until we get to what's called the terminal velocity, and that is where the air resistance of the bullet coming down, okay, matches basically the speed that it's going, so it can't speed up anymore. All right, as it goes down, the velocity of the air coming up is too much. All right, and it can't push, it can't accelerate anymore. If it was in a vacuum, like in space, for example, then it will just keep accelerating, all right, and that's sort of all dependent on the mass of the object it's getting pulled towards. But we don't need to know that. What we do need to know, what's interesting, is that it is a force, okay, in this example, pulling us directly downwards, all right? If there was an angle here, it'll basically be 90 degrees, all right? Most of the time when we're shooting on a flat range, bang, it's straight, okay, yeah, the bullet rises, whatever, but majority of that angle of gravity is pulling it towards the earth, all right? However, we're talking about angle shooting, all right? So now we're not shooting directly flat, we're shooting either down or we're shooting up. So we need to talk about cosine. So we've all heard of cosine before for wind, all right? When we take a shot, if the wind is directly to the 90 degrees, so either from 3 o'clock or 9 o'clock, okay, there is the full value of the wind. Yeah, we've heard about full value, half value, quarter value, and so on and so forth, and that is a cosine, right? It's cosine change. Cosine is just a word used in sort of angles and things like that, all right? We don't need to know that. What we need to know is what it's referring to is a change of angle, all right? So if we're firing directly straight forward and the wind is coming directly towards us or behind us, there's no wind value, all right? Because that force is coming directly in line with what where we're shooting, right? If we're coming from the side, okay, that force is directly coming from the side, all right? So it has its maximum amount of effect, all right? In this case, 1 o'clock, 50%, 2 o'clock, 86.6, we call it 90%, all right? But as we can see, as the wind changes, all right, it changes the strength that it has, or the strength of the force it imparts on our bullet, all right? So remember that. Okay, so we talked about how when the wind changes its angle, all right, the apparent effect on our bullet changes, all right? That angle is pretty much every 15 degrees it works. In the wind side of things, it is a cosine change, all right? Every 15 degrees is enough of a change that we have to then account that in our wind calculation, all right? However, we're now going to change that to gravity, right? Keep the same thinking, but think about gravity, right? So now we've got a bullet and it's flying flat, okay? Gravity then, like we know, if we're going straight, gravity's pulling us directly down. That's almost like a full value wind, all right? So instead of pushing us, all right, okay, imagine it's pulling us. So in effect, if we're shooting straight on, we have 100% the value of gravity, all right? That's one way to think of it. If I then change the angle, I change the cosine, I then start angling downwards. So in this case, 45 degrees, all right? 45 degrees in a wind perspective is 70.7, or sometimes around at 71, but 70.7% cosine, right? So there's 70.7% of the actual full strength of the wind. It's the same with gravity, all right? I'm angling down, all right? I now have, in effect, 70% of that apparent strength of gravity pulling me downwards, all right? Now, if I angle directly down, right, I'm shooting directly down to the ground, Now, just like if I had a headwind or a tailwind, all right, it's the same. I've now got gravity going in line with my bullet's trajectory, all right? So in effect, it's pulling with me, or it's working against me. However, it is perfectly in line, so there's not going to be no deviation, all right? So it's the same way to think about it as wind. It means then what we can do is we can adjust for gravity in the same way we can adjust for wind. Okay, so what actually are the cosines then? So in a wind perspective, every 15 degrees. However, angles can be obviously a lot more finite than that. And when you're really pushing out the distance, those angles can make a big difference. Big thing with cosine is it isn't perfectly linear. So actually, you'll find it's a bit more of a curve. So when we're nearer full value, all right, the jumps between are quite small, all right? So you can actually have quite a big angle that are having pretty much the same effect. However, as you start to get to those small angles, we find that actually there's big jumps between the cosine, all right? And we see that in wind when you're shooting from, say, a full value to, say, 90%, or even, say, 30 degrees either side. There's actually near enough 90 to 100% value of the wind, whereas when we're going from a 0 cosine, so straight head on, to 15 degrees to the right or left, and there's a 25% change, all right? So it's a bigger jump going from something, nothing to something than there is going from a full value to just off a full value. And we're same with gravity, okay? So I've written this backwards because when we're solving later on, it makes sense to go, right, what's my angle? Your angle from 0 rather than going from 90 down. Look, if we are shooting completely flat, right, and there's no angle, okay, we have 0, obviously it's the full value. I've put 0 there, but it's 100%, okay? What I'm saying is, like, we don't have to take anything into account, okay? If I'm 5 degrees lower, okay, I'm now at pretty much 100% of the force of gravity. Okay, 10 degrees, 98.984, 15 degrees, 965, 20 degrees, 939, 25, 906, 30, 86.6. So the only reason I read those out is because there is a small change in those. However, if I jump over to say 40, 45, 50, okay, we start off at 0.766, we then go to 707, we then go to 642, okay, so that's a much bigger jump, all right? So as I said, remember that curve, all right, it is, there's less of a value when you're pretty much at that full value gravity compared to once you're in those angles, then the cosine really starts to change. Okay, so how do we actually solve using cosine? So we have an example here, right? We're up on a vantage point, okay, we're shooting down, all right, or at least we want to shoot down. We get our LRF out and we laze the target. We see a target down here and we get a straight line distance of 740 meters, okay, for example. We then use some form of equipment to get our angle, okay? We could either use trigonometry and use a bit of Pythagoras and stuff, but most of the time you're not going to do that, all right? So you're probably going to use some sort of angle card, maybe a card with a piece of string on with angles already on there. You could use a protractor, you could use some form of spirit level with an angle in there, or a lot of LRFs now, you laze it and it tells you your angle already in there, all right? So however you've got your angle, and it is, in this case, we're going to say 50 degrees. Cool, so 50 degrees. All right, we know that the cosine for this is 0.642. So what does that actually mean? So gravity now, all right, has less apparent effect on our bullet. Obviously, it is affecting the bullet exactly the same. It's the same rate of acceleration, but there's an angle change, all right? So instead of it being 90 degrees, just like with a 90-degree wind, that is the full value of the wind, the full power of the wind, okay? We're actually at an angle, and in this case, okay, it's 50 degrees. So what that means is when we're shooting onto that 740 target, if we just put our elevation setting for 740, bearing in mind that's calculated for a flat range, all right, we now have less apparent effect of gravity onto the bullet, meaning that the bullet's going to get to the target easier. It means we're going to see the bullet go high, all right, and we'll explain why now. So what we have to do is correct this, this range, because whilst that is the straight line distance that the bullet is going to be travelling, all right, actually the amount of time the bullet's in the air, it's going to be the same as this distance here. All right, so this is what's called the hypotenuse, so the longest side on the triangle, okay, and this is the horizontal adjacent, all right, so in a right angle triangle here, put 90 degrees, all right, this is the actual distance, almost like the ground distance that the bullet would actually be traveling over, what we need to calculate for. So all I'm going to do, take 740, I'm going to times it by my cosine, and it will give me a corrected distance. So simple as, I'm going to do 740 times by 0.642, and that should give me a corrected distance. So 740 times by 0.642, and that gives me 475, thereabouts, we'll round it, meters. Okay, so now in effect, all right, I'm not actually shooting 740 meters, all right, I'm solving for 475 meters. So straight away you can see, if I put a 740 elevation setting onto my rifle and I shot, but the target's actually 475 meters away, I would go way over the top. All right, and this is the same for if I was shooting upwards or downwards. Okay, if I was here and I was shooting upwards, as you can see, the same, that distance stays the same. But if I set for 740 and I'm shooting upwards, I'll still go over the top. So whether you're shooting down or you're shooting upwards, okay, if you don't account for gravity, all right, you will hit high or you will miss high. You know, in this case, a big miss. You're almost 330 meters off. Okay, so as simple as that. So all you need to do is find out your angle, find out what that associated cosine is for that angle, and then just times it by your distance, and then that'll give you your adjacent. Pretty easy. Okay, so we've talked about how to solve the elevation side of things. So we know now that when you're angle shooting, you need to shoot using the distance from the adjacent, not the hypotenuse, okay? There's not the straight line distance, but like the ground distance, the flat line distance to the target. That's what we need to set our elevation for. However, the bullet doesn't care. The bullet is still experiencing 740 meters worth of travel to get to the target. And just like with gravity, okay, it's linked to time of flight. You know, the longer you're in the air, the more gravity is going to have the chance to increase your velocity towards whatever mass it's pulling you towards. All right, it's the same with wind. All right, if we're in the air for 740 meters, okay, we're going to have more wind deflection than if we were at 475 meters, and that's just a fact. If I said shoot that target at 475, okay, you took a shot, you made a winkle, you said 0.5. Once you got to 740, you couldn't use 0.5 again because you're in the air longer. There's more time for the wind to deviate you off course. So this is the rule. When shooting at angles, solve and elevate your turrets for the adjacent. However, you need to still come up with a wind solution for the straight line distance. Okay, so in this case, it would be elevation for 475 and a deflection for 740. All right, and you would do that deflection exactly the same how you would do if you were shooting flat. Okay, we can talk about some practical application now then. So, like we've already said, going from flat line to, or moving down pretty much to 30 degrees, okay, there isn't much difference. I mean, there is, of course, there's a difference, but it's really not as much. They're pretty much all within 100% or 90. So there is a rule that sort of learn in a professional environment, which is 30 and 300. The idea that anything less than 30 degrees, we can just take a shot and we don't have to worry about gravity. And 300 meters. If it's closer than 300 meters, straight line distance to the target, then we can pretty much negate it because the target sizes are probably big enough that any deviation is going to be kept within the tolerance of the target. By all means, if you can account for it and you have time to account for it, then by all means account for it. However, those are the kind of, that is the sort of the rule of thumb, 30, 300, 30 degrees, 300 meters. That is obviously with centerfire and depends on what centerfire rifle you are using. If you're using hot fast laser beams, then clearly that is going to hold pretty true. If you're using something like rimfire or using really slow or using subsonic or something like that, then clearly that's not going to work for you, okay? Because you're going to start to see that deviation sooner because it's time of flight. You're in the air longer, so gravity has more time to start giving you a relative velocity towards the ground. How can we actually solve for cosine? Okay, I appreciate that knowing the angle, working out the angle, and then having to sit there and go, oh, what is the cosine for that? Okay, yeah, kind of difficult. I mean, for most guys who depend on this without technology, all right, this sort of manual information, then by all means, you should have a pocketbook, you should have all your cosines written out, and then it's good to go. You can just look at it and go, yeah, sweet, that's what it is. Get your little pocket calculator out, boom, 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 done, all right? In the heat of a stressful engagement, clearly you're not gonna be able to do that, but in your stressful engagement, just start sending rounds down, okay? No, you've got to aim low. With technology though, or say analog technology, you can get what are called cosine indicators, which are fantastic. So I've got one here. Okay, that is a simple case of a little level, all right, and when your rifle's level, just goes on your pick, when you level, okay, it shows you what the cosine is. It doesn't give you an angle, because you don't need to know the angle. Really, I don't care whether I'm at 30, 32, 31, whatever, I just need to know what the cosine is, because that is what I'm gonna use to adjust my elevation, all right? So simple case, when I angle down, I have a look at it and go, okay, cool, I am at 87%, all right? And I could just use that and adjust my elevation. That's what I then set my turrets to, or that's what I hold for, all right? Okay, people actually neglect how steep angles actually are. If I took you onto a hill and I said, what is the angle? Okay, unless you're used to looking at angles, you'd probably get it wrong. Most of the time, because the angles that are actually going to start to really affect your bullet are a lot steeper than most settings are. The only time we really see high angle shooting is if you're on mountains, cliffs, somewhere where there's big jagged sort of drops or buildings, things like that, where it's very, very manufactured. If you're shooting on just rolling hills and stuff, most of the time you're not going to find an angle that is steep enough. Otherwise you'll find that, like, you know, soil and rocks and stuff will start moving, landslides and stuff, you know. So actually, you'll find that the angles are going to be less, and you won't have to think about this as much, but it's a fun thing to do. You know, if you're like me on the range and you want to go, right, I want to shoot that target, that part of the target, and I want to calculate everything because why not? I've got rounds to spare, and you know. Okay, another thing you can do is hand angles. So when we shoot and we're working out the wind, okay, the cosine, we know that every 15 degrees it is roughly a cosine change, or well, it is a cosine change. Okay, we can pretty much do that with our hand. So a fantastic tip I was taught by an instructor on Actually First. Okay, put your thumb out, finger thumb, make a thumb, and then that angle from where you're looking to back end of your hand to the front end of your thumb, okay, it's 15 degrees, there or thereabouts. And you can use that exactly the same for angles. If you want to say that top line is straight line, the bottom there's 15, bottom end there's 30, bottom end is 45, and so on and so forth. Okay, you could get really pesty and you could set up some form of angles on your walls, whatever, and stick your hand out and go, right, what is, if I spread my hands, what is that equate to? What does that distance equate to? And then you could do something like that in a pinch. Okay, then again, you've got to remember what the cosine is. However, that is a possibility, 100%. Again, just want to think of things that don't put out any form of signature, or they don't run out of batteries. Cool, so I want to finish off with some key takeaways. Okay, so first off, up or down is exactly the same. Okay, you're always going to hit high if you do not take into consideration gravity cosine. Gravity then itself, 9.8 meters per second. Just like wind deflection, the longer your bullet is in the air, okay, the more time the wind is going to have to affect your bullet. It's exactly the same with gravity. The longer you're in the air, the more times you're going to accrue that 9.8 meters per second, every second until you hit terminal velocity. Okay, cosine isn't linear, all right, like we said. If you're going from a full value to just off a full value, just off of that, okay, it still pretty much becomes, you can round it to full value up to about 30 degrees. And then after that, okay, we start to have bigger jumps, all right? So that's where the 30 and 300 comes from. We'll talk about that in a second. Elevation for flat line, okay, so not the hypotenuse, not the laser straight line to that, not the elevation for that. We want the elevation for the angle from you, or the distance from you to the target, okay, the flat line distance. That's what we need to solve for. In effect, it's shorter than where you're shooting or where you're lasering. Wind for the straight line distance though, okay, because the bullet is still flying over that distance, still in the air for that amount of time, okay, so we still need to get a wind call for the straight line distance, right, just like we had the 740 and the 475, and then 3,300, all right. Obviously, by all means, have a look at your rifle, have a look at your setup. If you're ultra fast, okay, then you'll find that you can probably work with this, anything up to 30 degrees. You won't have an issue, all right, you can pretty much just shoot, and yeah, you might be a little bit high, but it's within your target tolerance, and 300 meters in. Trajectory is really flat, up to 300 meters for most centerfire rifles, operating in that 26 to say 3,000 feet per second mark plus. So we can pretty much get away with just going, target's big enough, bang, all right. If it's further than that, then we definitely need to account for it. If you're running subsonic or you're running rimfire or whatever, or a slow bullet, then you definitely need to look at where your tolerances are, because it might be a 20 and 200, it might be something slightly different. Have a look at angle cosine meters, little measurers that you can get just for Piccadilly. Don't take any batteries, and they're quite handy if you are thinking to do some angle shooting. Otherwise, you can just use a straight up protractor and a little piece of string, measure it, just make sure you've got written down the cosine, and then solve your elevation. Easy as that. Okay, thank you very much for watching. I hope you enjoyed that video. If you want more sort of technical videos, then please let us know in the comments, and let us know what you'd like to see next. Cheers.